So now we've written our program and proved it out, and now we want to start running production. So I am going to switch over from the block that I programmed this with. That was part number 1 out of 5 that we're making, and here's part number 2 out of 5. So I'll put that back on our fixture, being careful to follow the 3, 2, 1 alignment. I'll pay attention to the position of my clamp here, make sure that I'm not orienting it differently than it was originally oriented. We did get pretty close to the clamp as we're moving around the part. And now I want to go execute my program. So to execute programs, the way I think about it is characteristics list is in the order that you want things to show up in the dimension report. So you want your characteristics list to be ordered sequentially based on your balloon numbers. Your features tab should be written in such a way that this program is path efficient, meaning you're not going back and forth over long distances to touch a point here and then a point there and then a point here and then a point there. So we're going to grab all of our features here. We'll click on the bottom, hold shift and click on the top, and we'll click run. And if we want, we could do a manual alignment, but we haven't moved the position of this part at all. We're now in production mode. So this is what production mode looks like. We want to clear existing results. We can't do current alignment. Current alignment is highlighted in yellow for a reason. It's really only for while you're writing a program, and if you want to add 1 or 2 very small features to an existing program that has a lot going on, you don't want to reperform the alignment. But current alignment will not be your standard selection. You'll either be doing manual alignment or the named alignment. Named alignment will always be the third one down in the list. When in doubt, do the manual alignment. If you know exactly what you're doing, go ahead and do measurement or the named alignment, in this case measurement plan 1. By doing the named alignment, it will not prompt you to touch points on the part before it executes the program. It will simply execute the program. Now it's important to note that you need to have a clear, unobstructed path from where the probe is to where the part is to be able to do this. If we had a clamp that was in the way, the first thing that's going to happen is the machine will move diagonally over to the first point. So we may also want to just get a little bit closer to the part, knowing that the first point in the base alignment is right up there in the corner. And then, of course, we'll slow our speed dial all the way down. So, clear existing results. Named alignment, which is measurement plan 1 in this case. We could do all characteristics or current selection. If you're running production, you can do all characteristics. If you're doing what I've done here and you're selecting everything, current selection will have exactly the same effect as all characteristics. But if you think about it, if all you're trying to do is get every characteristic on the dimension report, that's a pretty good option as well. I know this seems confusing now, but there's a lot of power to how they have this window laid out. There's a reason why they do it like that, and that'll be explained in future tutorials. For order of run, my default here is features list. Remember, we made the features list path efficient so that we're not moving too far when measuring our program. We did not make our characteristics list path efficient, so my default is features list to make sure my program runs as quickly as possible. You also have to be careful with characteristics list. If you run from characteristics list instead of features list, you can create situations in which moving to your clearance plane will cause the probe to crash. So good default here is features list, clearance plane, slow through first feature, and our speed, we want to just highlight that and type in 55 if it's not already there. Close the speed dial all the way down and hit start. Then we'll slowly open up that speed dial. And the program will run. Now you notice the program is running the base alignment as part of the program. Another way of saying this is you have your manual alignment that's used to tell the machine where the part is when you set up the job, and then you have the automatic alignment or base alignment. In the automatic alignment or base alignment is when the machine refines the exact position of this part. And the reason you would want to refine the exact position of this part is every part sits in a slightly different position. So there the program ran. Zooming in on this, I can see that we have, at a glance, every dimension is good. Now, I should do a manual verification on this. I did do that in the last segment of this tutorial. The manual verification does two things. Number one, it makes sure we didn't take any bad hits on this part, but probably more importantly, it checks the correctness of the program. Well, if the program was correct last time we ran it, there's no reason why the program would be incorrect here, so a lot of times I'll only do a manual verification on the first part, maybe the first couple parts, and then I'll do a manual verification if I see that something is out of tolerance. If everything is in tolerance, there's a near 0% chance that the part is actually bad when the CMM says it's good, because the chances of everything falling in such a tight window and everything being correct is really, really low. However, if you find that multiple dimensions are out of tolerance, that doesn't necessarily mean that your program is bad. It could just mean that your probe is not calibrated. It could be as simple as that. All right, so let's move the probe out of position, and we are now going to, let's get ahead of myself here. Let's go File and Print, and we are going to print this to a PDF. So we'll select Export PDF, and we'll hit Print. And in this case, I'll save this to the Downloads folder, and I'm going to save this with my initials, and then an underscore. And the name of this part is Block 1. And the block itself is number 3. So Block 1, Part 3. And if you've run the part multiple times, you might want to put run number 1, run number 2, run number 3. Now, why would you run the part multiple times? Well, maybe you want to make sure that your program is giving you repeatability. You want to make sure if you run the same exact program multiple times without changing anything, you actually get the same results. And you'll find if you have a stylus that's loose on there, you won't get good repeatability. So that's my standard format. This is the student's first and last initial. That is the name of the lab. That is whichever one of those parts this is. This is part number 3 in this case. And however many times you've run it. And then we'll hit save. And now this can be opened back up as a PDF later. Say yes to open it up right now, and it'll look exactly the same, but the only difference being now this can be opened on any computer, whereas Zeiss's preview here requires a PyWeb license to open it. So now we're ready to run our next part. So we will take off our clamp here, we'll set our completed part over here, and we have 4 more parts to run. So make sure we're putting this with the labeling up. This happens to be block 2. We have our 3, 2, 1 alignment here. Clamp our part down, and you guessed it, we'll come over to Features List, click on the top, hold Shift, click on the bottom, we'll hit Run. Everything that we set last time should still be set. We'll just slow our speed dial down. Well, actually, we are manually going to move a little closer to the part first, and then we'll slow our speed dial down and hit Start. As soon as we see it start moving, we can turn the speed dial all the way up. So the key point here being when you're in production mode, you want to use the named alignment. You want to use the named alignment because you want to make sure that you are performing the alignment at the beginning of the program to find this actual part exactly where it's sitting right now. But you don't want to have to do a manual alignment where you re-find the part at some other location in space. Now, the next thing I'm going to show you is what happens if this fixture is slightly moved in space from where it was last time. Well, let's say we're done with this, we're going to put on the next part, and we accidentally skewed this. So you can see a little bit of a gap here where I've moved this off location. I'll come in and save the dimension report. It looks like this part actually is bad, so we would want to do a manual verification on that to make sure it really is bad and make sure we didn't take a bad hit here. But for right now, I'll go File, Print. We'll deal with that later. We'll go to Export PDF and Print, and it's going to be the same as last time, except this happens to be part number 2 instead of part number 3, and I'll hit Save. All right, and now I'm going to swap out this part. I'm going to grab my next part, which happens to be part number 5. I'll put this back in here. And I'll come over to the Features tab, click on the top, hold Shift, click on the bottom, hit Run. I'm going to leave everything the same here. Slow the speed dial all the way down and hit Start. And then I'll slowly open up this speed dial and notice that we actually missed the part. In fact, looking at the computer screen, we can see that the stoplight window turned itself to red. We have all this red text in our status window over here telling us, let's see, nominal probing point with position or step command not within search path. Basically, the machine moved further than it expected to before it received any signal, so it stopped itself. So that's a safety feature. Well, the reason for this is we moved the part in space, and we're not within, let's say, plus or minus an 1/8 inch of wherever we had the part initially. So the named alignment only works when you're trying to run production, when you are trying to simply execute the exact same thing that you just did. Now in this case, our fixturing is designed to be repeatable. We have magnets over here, so that way if I just push this back into position, it will locate in the correct position within a very, very small margin, probably 5/1000ths or less, automatically. So if I come over and try to do the exact same thing again, I'll come into the Features tab, click on the top, hold Shift, click on the bottom, click Run. I'm not going to change anything. Slow the speed dial all the way down and hit Start. Notice that it comes over and finds the part just fine. So as far as a named alignment is concerned, named alignment will re-find the part at the beginning of every program. However, the part has to be located within, let's say, plus or minus 25/1000ths in a perfect world. A lot of times you can get away with locating it within plus or minus 100,000ths, but plus or minus 25/1000ths will definitely work. All right, so now it finds the part, no problem. In the next tutorial segment, we'll talk about how to re-find a part if you need to set it up in a different location, or perhaps you're trying to run a part that you programmed last year.